のテーマを担当させていただきます。メルカリ US 機械学習部の原ジェフとします。私はメルカリ US で機械学習エンジニアを担当しており、主に AI エンジニアリングを管理しております。生まれも育ちもアメリカですが、実は純粋な日本人です。しかしそこまで日本語は話せないので、初回ぐらいでも精一杯です。今回は少しでも皆さんの参考になるお話をできるように努めてまいりますので、最後までお付き合いのほどどうぞよろしくお願いいたします。では早速テーマに移ります。いいか、英語に移ります。Hello, my name is Jeff Hara, and I'm a junior machine learning engineer here at Mercari US. I graduated from Stanford University with a degree in computer science and philosophy, and I started at Mercari in July of this year. I'm super honored to be invited to the 2018 Mercari Tech Conference, and I'm very excited to be speaking with you today at my first talk at my first conference, so I'm really excited to be here. The title of my talk is Learning to Think Like a Machine, and I'd like to talk about some of my insights into what I believe is the future of machine learning at Mercari. So before I start, I think some of you might have a couple questions. One, what exactly is a machine learning engineer? And second, what exactly am I doing here as a junior? To answer the first question, if you go on LinkedIn or Indeed or Economy, you might find positions for machine learning researcher, machine learning engineer, data scientist, or machine learning software engineer. I think the last slide said I was a software engineer in machine learning. Well, the point is, it's not really clear what exactly a machine learning engineer is. At Mercari US, a machine learning engineer is responsible for coming up with AI solutions for every part of the company. What that means is, I would consult with the team, understand what types of problems they're facing, and then try to come up with some sort of data-driven AI solution. That all sounds a little bit complicated, but basically a machine learning solution is one where the system gets better at some task with more data. In just a few short months, I've been working with the customer experience team, the search team, and business intelligence team to come up with data-driven solutions and improve our product in a smart way. Now, the second question is a little bit more complicated. What am I doing here? I think that there are much more knowledgeable and experienced people that could represent the machine learning team. But today, I hope that I have a unique position as someone who is just out of college and just entering the company and just starting to see the birth of the data science team. And I hope that I can bring some perspectives about what I've learned and maybe share some ideas about where I think the team is headed. So what exactly do I mean by learning to think like a machine? Surely a machine cannot actually think. I took philosophy in college, so you can take it from me. What I want to motivate here is that I think that machine learning engineering is fundamentally different from software engineering. I think that in order to really understand what machine learning is about, you kind of have to stop thinking like a programmer. Machine learning truly is a paradigm shift, and I think that machine learning is going to be the next evolution of software. Thanks to new frameworks and platforms and online education, machine learning has never been more accessible. It's something that everyone can learn, and it's something that everyone can master. The trick is that you need to learn how to think about the problem differently. I'll start with a quotation from Andre Karpathy, the director of AI at Tesla, who makes the distinction between software and machine learning. He actually calls machine learning software 2.0, and he says that machine learning is taking over a lot of the software stack at Tesla. So what is it that makes machine learning so different from software? What is it that makes a machine learning engineer so different from a software engineer? I think the answer lies in how we solve problems. In a nutshell, I think that software engineering is top-down problem solving. Here's an example. Let's say I have to write a program about how to bake a cake. Everyone knows that you need to start by beating the eggs and making the batter and putting it into the oven. Basically, there's this recipe, and you have to follow this set of rules, and if you know what the recipe is first, then you can come up with the solution. You have to start kind of at the top and then work your way down with the details. Now, there are some issues with this. What if you don't know what the recipe is? What if the recipe is a little bit too complicated? What if you end up with these half-baked heuristics? Then what do? I would argue you need to start thinking like a machine. A machine learning solution is one where the system gets better at some task with more data. The first key point here is that we don't give the machine a recipe. We give it data. And the second key point is that we have to start with the notion that we don't actually know what the answer is. We start with the low-level data, and once we have the data, we come up with a task, and once we have the task, we come up with a model, and if we do all those steps right, then we can come up with an answer. I call this a bottom-up problem-solving solution. Now, if you've been following, it sounds like the machine is the one that comes up with the recipe, the machine is the one that's really the programmer. So why do you need someone like me? Why do you need a machine learning engineer? One answer is that a machine learning engineer sort of acts like a doctor. When the model isn't working, we have to step in and figure out what is going wrong. And with machine learning, there's about 1,000 different things that can go wrong, so it's quite a challenge. Sometimes you have to clean the data, other times you need to do more feature engineering, other times you need to add more model complexity, sometimes you just need to add more data. But that's not all. The other thing a machine learning engineer has to do is to come up with the problem. I think a lot of people have kind of a pop culture understanding of machine learning, and they think that machine learning can solve any problem. It's like machine learning is magic. You just give it data, it'll give you the answer. Well, that's not exactly true. Basically, there's certain types of problems that machines are good at solving, and it's our job as the machine learning engineer to map the problems that the computers can solve to the types of problems that we actually want to solve. Our CTO, Mook, will sometimes tell me, what is the story in this data? And I think that that's a really interesting way to look at how we solve problems in machine learning. This is sort of the workflow that I use when I think about a machine learning solution. And what data do we have, what story is being told, and then finally what type of problem we can solve. And the order here is important. We have to start with the data first. Once we have the data, then we can start asking questions about it. Then we can start wondering, what is the story being told here? What is significant about this data? What types of patterns do we see in this data? And maybe most importantly, what could a machine possibly learn from this data? Once you start to ask these questions, then you can start talking about what types of problems you're able to solve. Let me give a few examples. So in our data set, we have a database of all these transactions that occur on Mercari. Things like what item got sold, what category it was, what brand it was, who bought it, who sold it, at what price. And we also have the status of the item, whether it got eventually completed or whether it got canceled, and so on. So when we looked at this data, when we wondered, what is the story being told here? We started to wonder, can we predict what the future status of the item will be? We decided to do exactly that. We made two prediction models. One to predict how likely an item will be sold, and one to predict how likely an item might be canceled. The outcome of this was that we could apply it to our search results. Basically, we could rank the items that are more sellable higher, and then de-rank the items that are more cancelable. In early A/B testing, this showed that using both models together created the greatest boost in our GMP. Additionally, the sellability model is we can use the sellability model in the advertising team to make more effective and compelling ads, and we could use the cancelability model for the customer service team to identify fraudulent accounts. My point here is that one model can be used in multiple different contexts, so the power of one can be very, very powerful. It's impactful, I would say. Another example is our database of search queries. And the story here was that people were using different words to talk about the exact same item. For example, someone might say PlayStation 4, someone might say PS4. We need to find some way to recognize that these are talking about the same thing. The machine learning team came up with a deep learning NLP model that was able to make this comparison, and that is one of the core technologies of our improved search program. What I think is so cool about machine learning is that it doesn't just stop there. Once you build one model, you can build another model right on top of that one, and we can continue to build models on the last model's successes. You kind of see this like a building block. For example, I was just discussing the the text similarity module. And if we have text similarity, we can start to do item similarity. And once you have item similarity, you can start to do user similarity. And then once you have item and user similarity, you can build collaborative systems to make recommendation systems, and so on. The roadmap I've placed here just kind of gives you an idea of the types of projects that we're working on currently. And you can see that some of these projects are actually directly dependent on each other. I think that this is really cool because we get to be really creative about how we solve problems. Yes, it might be true that machine learning can't solve every problem and that machine learning isn't magic. But what's so cool is that we can continue to add and stack these models to create more and more interesting and complex solutions that, as was mentioned in the keynote speech, any sufficiently advanced technology is indistinguishable from magic. So it's our job as a machine learning engineer to be the magician. What I think makes our machine learning project so promising at Mercari is the fact that we have so much data between Japan, the US, and the UK. Between all these different data sets, we have so many stories that still haven't been told. And I think that this is where we really stand out as a company. I think that using this data well is going to be the differentiator between whether or not we can succeed as a global company. So just to recap, I think that the three important things about being a machine learning engineer are the following. One, we need to find stories inside of the data. Then we need to use that data and use that insight to create these powerful models. And finally, it's our job to integrate these models to create a smarter, data-driven solution. We've actually been sitting on all this data for years now, just collecting and collecting and collecting. And I think it's really interesting to create a data science team at this juncture because we're able to really make use of it now. There's so many opportunities still waiting to happen, so many stories still left to be told. And if we just use a little bit of creativity, if we start to think a little bit less like a programmer and a little bit more like a machine, I think we could bring about the next evolution of software to Mercari. Thank you very much for your time.